Hello everyone, I am Aliakbar, an engineer passionate about the future of transportation, and I am excited to be your guide on this educational adventure. Today, we are delving into the fascinating world of electric vehicles where innovation meets sustainability. Electric vehicles or EVs represent a revolutionary shift in the world of transportation. If you are new to this topic or want a refresher, we have covered the basics of EVs in a previous lecture. Our goal in this video is simple but essential: to explore the different type of electric vehicles and provide you with a clear understanding of the exciting options available in the world of clean and efficient transportation. So let's get started by taking a look at the different type of electric vehicles. As we embark on our journey through the classification of electric vehicles, it's essential to have a roadmap of what lies ahead. In this lecture, we will explore electric vehicle categorized in 4 main ways, providing a comprehensive understanding of this innovative field. Let's consider the broader classification that will guide our exploration. Electric vehicles are classified based on powertrain configuration, technology and innovation, vehicle size and type, and based on intended use. Let's start our journey into electric vehicles with a category based on powertrain configuration. Our first stop, battery electric vehicles or BEVs. Battery electric vehicles or BEVs for short are at the forefront of electric mobility. They are designed with one primary focus: to run exclusively on electricity stored in a high capacity battery pack. This means no internal combustion engine, no tailpipe emissions, and a quieter, smoother ride. From an engineering standpoint, BEVs are all about high voltage direct current systems. Their electric motors, powered by lithium-ion battery packs, deliver impressive torque and power to the wheels. As of 2023, one standout example of a BEV in the market is the Tesla Model 3. Tesla has revolutionized the electric vehicle industry, and the Model 3 is known for its impressive range, cutting-edge technology, and exceptional acceleration. Did you know that BEVs are not only environmentally friendly but also incredibly efficient? Electric motor used in BEVs can convert about 85 to 90% of the electrical energy from the grid to power at the wheels, whereas in internal combustion engines in traditional cars typically operates at only about 20 to 30% efficiency. This efficiency means that BEVs can travel more miles on the same amount of energy compared to gasoline or diesel vehicles, making them an efficient and sustainable choice for transportation. Now, let's shift our focus to the next subcategory within powertrain configuration, that is plug-in hybrid electric vehicles or PHEVs. PHEVs are a fascinating engineering blend. They have both an electric motor and an internal combustion engine, providing adaptability in power source. The electric motor is powered by a high capacity battery just like in BEVs, allowing for all electric driving. When the battery is depleted, the internal combustion engine kicks in, extending the vehicle's range. One of the key features of PHEVs is the dual power source capability. They can operate in all electric mode for short commute and urban driving where emissions are a concern. On longer journeys, the internal combustion engine takes over, offering extended range without needing frequent recharging. A notable example of a PHEV currently in the market is the Mitsubishi Outlander PHEV. This SUV combines an electric motor with a gasoline engine, offering an electric-only range for daily commutes and the ability to use gasoline for longer trips. Now, let's continue our exploration within the powertrain configuration category with hybrid electric vehicles or HEVs. Did you know that HEVs were among the first to introduce the concept of regenerative braking? This innovative technology allows HEVs to capture and reuse energy during braking, making them more efficient. Hybrid electric vehicles or HEVs represent a blend of electric and internal combustion engine technology. They feature an electric motor and a gasoline engine similar to PHEVs. However, unlike PHEVs, HEVs do not have a plug-in capability to recharge the battery externally. One of the key advantages of HEVs is the synergy between the electric motor and gasoline engine. The electric motor assists the gasoline engine, particularly during acceleration and low-speed driving, reducing fuel consumption and emissions. And as I mentioned earlier, HEVs employ regenerative braking. When you apply the brakes, the electric motor operates in reverse, acting as a generator and converts kinetic energy back into electrical energy, which is stored in the battery for later use. A prominent example of an HEV on the market today is the Toyota Prius. The Prius has been a pioneer in hybrid technology for years, known for its excellent fuel efficiency and reliability. It's a prime example of how HEVs have become a practical and eco-friendly choice for many drivers. Now, let's turn our attention to another groundbreaking innovation in clean transportation, which brings us to our fourth subcategory of powertrain configuration: fuel cell electric vehicles, or FCEVs. Fuel cell electric vehicle represents a pioneering approach to clean transportation. Instead of relying on traditional batteries or internal combustion engines, FCEVs use hydrogen as a fuel source to generate electricity. At the heart of every FCEVs is a hydrogen fuel cell. This cell combines hydrogen with oxygen from the air, undergoing an electrochemical process that generates electricity to power the vehicle's electric motor. The only byproduct this process emits is pure water vapor, making FCEVs emission-free at the tailpipe. A notable FCEV example on the market is the Hyundai Nexo. The Nexo showcases the advancements in hydrogen fuel cell technology, offering a clean and efficient driving experience. Now, let's shift our attention to the category based on technology and innovation, starting with autonomous electric vehicles, or autonomous EVs. Autonomous EVs represent a fusion of cutting-edge technologies. At their core are advanced artificial intelligence algorithms and sensor systems. This vehicle uses a combination of sensors like LiDAR, radar, camera, and GPS to perceive their surroundings and make real-time decisions. Engineers classify autonomous vehicles into different levels of automation, ranging from level 0, that is no automation, to level 5, that is fully automated. Achieving higher level of autonomy requires increasingly sophisticated technology and testing. A recent example of an EV with autonomous capabilities is the Tesla Model Y, equipped with Tesla Autopilot system. While it's important to note that we are not yet at fully autonomy, that is level 5, this vehicle offers advanced driver assistance features such as adaptive cruise control and lane keeping assistance, moving us closer to fully autonomous driving. Now, let's delve into the second subcategory within technology and innovation, that is connected electric vehicles, or connected EVs. Connected EVs represent a convergence of automotive engineering and digital technology. These vehicles are equipped with advanced communication systems, sensors, and software that enables them to connect to the internet, other vehicles, and even infrastructure like traffic lights. Engineers have developed systems that allow you to remotely monitor and control various aspects of your EV. You can check your electric vehicle's charge status, precondition the cabin temperature, and even lock or unlock the doors, all from your smartphone. A recent example of a connected EV is the Chevrolet Bolt EV, equipped with My Chevrolet app. This app provides drivers with real-time vehicle information, remote control features, and even allows for over-the-air software updates, keeping your EV up to date with the latest enhancements. Now, let's explore the third subcategory within technology and innovation, that is fast-charging EVs, or fast-charging electric vehicles. Fast-charging EVs represents a significant advancement in electric vehicle technology. These vehicles are equipped with high-voltage systems and fast-charging connectors that can deliver a substantial amount of electrical energy to the battery pack in a short time. Engineers have developed fast-charging systems that can recharge an electric vehicle's battery from empty to around 80% capacity in as little as 20 to 30 minutes, depending on the vehicles and charger type. A recent example of a fast-charging EV is the Porsche Taycan. The Taycan is known for its lightning-fast charging capabilities, with the ability to gain approximately 60 miles of range in just 4 minutes of charging. This sets a new standard for EV charging speed. Did you know that the energy delivered during fast charging sessions is often as high as 350 kW or more? To put that into perspective, that's like charging your vehicles with the power equivalent to over 200 average household outlets combined. Now, let's explore the fourth subcategory within technology and innovation, that is range-extended electric vehicles or range-extended EVs. Range-extended EVs represents a clever engineering solution to address the challenge of limited electric range. These vehicles are primarily electric, using a battery to power an electric motor. However, they also feature an onboard generator, often fueled by gasoline or another energy source that kicks in when the battery is nearly depleted. This dual power system extends the vehicle range significantly. When the battery charge is running low, the generator can recharge the battery or directly power the electric motor, providing extra miles to reach your destination or the nearest charging station. A recent example of a range-extended EV is the BMW i3 with range extender. This innovative vehicle combines an electric motor with a small gasoline engine, offering the flexibility of extended range when needed, making it suitable for a variety of driving scenarios. And speaking of innovation, just like how electric vehicles are revolutionizing transportation, the Scholars Club is revolutionizing the way students like you navigate their academic path. Whether you are struggling with assignments, project or thesis work, or in need of a perfect tutor who understands your academic requirement inside out, the Scholars Club has got you covered. With just a sign up, you unlock a world of possibilities. Fill out your academic details and budget, and their cutting-edge machine learning platform will do the rest. Watch as your requirements spread across the platform, attracting the perfect tutors who's tailor-made for you. It's like magic, and all-in-one experience where you can choose from a pool of proposals sent by the tutors or manually search for the ideal tutor using the state-of-the-art search engine. And now, here's the best part. Visit thescholarsclub.com or download the user-friendly app from the Play Store or Apple Store. Your academic success awaits. And now, coming back to our lecture, let's dive into the fascinating world of electric vehicles categorized by their size and type, catering to various preferences and needs. First is micro EVs. Micro EVs are the smallest member of the EV family. These compact and nimble vehicles are ideal for navigating crowded city streets. Micro EVs are often used for short trips and are known for their energy efficiency. An example is the Renault Twizy. Second is compact EV. Compact EVs strike a balance between size and versatility. They offer a bit more space and range than micro EVs while remaining efficient. A recent example is the Nissan Leaf. Third is mid-size and large EVs. Mid-size and large EVs cater to those who need more space and longer range. They offer ample seating and cargo capacity, making them suitable for families and longer trips. The Tesla Model 3 is an notable example in this category. Fourth is electric minivans. Electric minivans brings eco-friendliness to family transportation. They provide spacious interiors and a range suitable for daily driving needs. The Chrysler Pacifica Hybrid is an excellent example. Fifth is electric truck. Electric trucks are making waves in the commercial and consumer markets. These vehicles offer powerful performance while eliminating emissions. The Rivian R1T stands out as an innovative electric truck. Sixth is electric vans. Electric vans cater to businesses and delivery services looking to electrify their fleets. They offer practicality and efficiency. The Ford Transit Electric is the prominent choice for commercial use. Seventh is electric sport vehicle or electric sports cars. Electric sport cars combine exhilarating performance with green technology. They offer lightning-fast acceleration and a thrilling driving experience. The Porsche Taycan is a remarkable example of an electric sports car. Now, let's explore the diverse world of electric vehicles categorized by their intended use, catering to a wider range of needs and applications. First is personal EVs. Personal EVs are designed for individual use, offering eco-friendly and cost-effective transportation for daily commutes and errands. They are compact and efficient, making them ideal for urban environments. A recent example is the Hyundai Kona Electrics. Second is commercial EVs. Commercial EVs are tailored for businesses and enterprises, providing clean and economical solutions for fleets, deliveries, and logistics. They offer various sizes and configuration to meet diverse commercial needs. The Ford Electric Transit is a recent example designed for electric commercial mobility. Third is public transportation EVs. Public transportation EVs revolutionize urban transit with zero emission options for buses and trams. They reduce air pollution in cities and provide a quieter and smoother ride. The Proterra Catalyst E2 is a notable example in this category. Fourth is specialized EVs. Specialized EVs cater to unique and specific applications, from electric motorcycles and scooters to electric golf carts and off-road electric vehicles. They serve various purposes, from recreation to specialized work tasks. The Zero SR/F electric motorcycle is a recent example of specialized EVs. And that, my friend, brings us to the end of our lecture. I hope you have found this journey through the world of electric vehicles as fascinating and enlightening as I have. Before we wrap up, I would like to hear from you. Did you gain valuable knowledge from today's lecture? If so, don't forget to show your support by hitting that like button, sharing this video with others who might find it helpful, and subscribing to my channel for more in-depth exploration of engineering and technology. Thank you for joining me today, and until next time, keep exploring, keep learning, and keep innovating. This is Aliakbar signing off.